Hi AAT. This is Chapter 7, Trigonometry, and this is our first section, 7-1 right triangle trig. You may remember a lot of this from geometry. When we have right triangles are awfully special. We can do so much with them. And we know from geometry and from before, all angles in a triangle, of course, are 180 degrees. And if it's a right triangle, one angle is a 90, so the other two have to add up to 90. So you know these two angles, for instance, add up to 90 degrees. We also know the relationship of Pythagorean theorem, that the two smaller sides squared sum up to be the hypotenuse squared. Remember from geometry, your relationship of sine, cosine, and tangent. Sine, cosine, and tangent are functions that relate the sides of a right triangle. So these are all ratios. A sine, a cosine, and a tangent are equal to ratios for an angle, x. So if we have this angle, it's something degrees, x degrees. The sine of that angle would equal the opposite side over the adjacent, over the hypotenuse, excuse me. So if, for instance, I put numbers to these, so let's say this was 3 and this was 4, what would our third side be? It would be 5. That's a Pythagorean triple. Remember, 3 squared plus 4 squared is equal to 5 squared. 9 plus 16 equals 25. So a 3, 4, 5, as long as 5 is the hypotenuse, is always going to work on a right triangle. So if we try to find the sine of angle AX, we're looking for the ratio of the opposite side over the hypotenuse, 3 to 5. For the cosine, it's the adjacent side, and the adjacent side is just the one that's next to the angle that's not the hypotenuse. 4 to the hypotenuse, 5. And the tangent is the opposite side over the adjacent, 3 to 4. So those ratios will always be true in a 3, 4, 5 triangle. And so if we did like a 30, 40, 50 triangle, they would still simplify. We'd have 30 over 50, for instance, for the sine, and it would still simplify to 3 and 5. Okay, so this is what's going on here. 3, 4. So first thing we would do is find that missing side using Pythagorean theorem. So if we don't see that it's a triple, we would have to actually work Pythagorean theorem out to find the third side. So you take a second and find the sine, cosine, and tangent of all of these angles, but be careful. The first one is asking for the sine of A. The opposite side for angle A is a 4. This one's asking for the sine of B. The opposite side for B is the 3. So pause the video a second and see if you can find all of these ratios. You shouldn't need your calculator. You're just finding the relationship like we did over here. So here is your answers. Notice the sine of A, opposite over hypotenuse, is 4/5. The sine of B, opposite over hypotenuse, is 3/5, and it's reversed for cosine. So there's all the ratios. Check and make sure you have that right. So find the missing sides of the triangles below. So here we have a 30, 60, 90 triangle. We already know the relationship between a 30, 60, 90. If you remember from geometry, across from the 30, your smallest side, whatever it is, get this where you can see it, you double it to get the hypotenuse, and you take that smallest side and multiply by √3 to get the side that's across from the 60, or the longer leg. So if this is 30, this is 60, this would be the side across from the 60-degree angle, which would be 30 √3. The smaller side times √3. We would find that same thing by using Pythagorean theorem. So here, we really only need one side. We don't need two sides if we want to use a 30, 60, 90. Whatever the hypotenuse, that's 2 times x. So x would be half of 70 if we solve that equation for x. So our side across from 30 would be 35. and the longer side, the longer leg, would be 35 root 3. So now that we know that, we can find all these relationships, and notice it doesn't matter what numbers were given. These triangles are totally different triangles. However, they're both 30, 60, 90 right triangles. So on this triangle, for instance, the sine of 30 is opposite over hypotenuse, 30 over 60, which simplifies to 1/2. On this triangle, the sine of 30 is 35 over 70, opposite over hypotenuse, which also simplifies 1/2. So the sine of 30 is always the same thing. The sine of any angle is always the same ratio, regardless of what the sides of the triangle are, because they always end up with those same ratios because of the angles. Okay, so let's find the cosine of 30. Cosine of 30 is adjacent over hypotenuse, so that's 30 root 3 over hypotenuse 60. And we can simplify outside the root. 30 over 60 is 1/2, so that's root 3 over 2. And the cosine of 30 on this triangle, adjacent, 35 root 3 over hypotenuse 70. We can simplify that, which is also root 3 over 2. So again, cosine of 30 will always be root 3 over 2. And the tangent of 30, tangent, remember, is opposite over adjacent. So opposite is 30. Adjacent side is 30 root 3, which simplifies to 1 over root 3. Remember, we want to rationalize when we can. If I multiply by root 3 to get that root off the denominator, I get root 3 over 3. So the tangent of 30 should also be root 3 over 3, but let's make sure. Opposite is 35 over adjacent side is 35 root 3. If we simplify, we get 1 over root 3 and rationalize. Again, we get root 3 over 3. Okay, so before we turn the page, remember on these that there's a couple different ways to memorize how sine, cosine, and tangent are related. Some people remember sine, opposite hypotenuse, cosine, adjacent hypotenuse, tangent, opposite adjacent, which is written sometimes as SOH, CAH, TOA, SOHCAHTOA. So you can memorize it that way, or sometimes people, if you look at any calculator, it's always listed in the way, if we look at our calculator here, sine, then cosine, then tangent, and sine, cosine, tangent in that order is Oscar had a heap of apples is another way you hear it memorized, but you do need to know what those relationships are. Another reminder for your Pythagorean triples, remember we have 3, 4, 5 from geometry, but also you always need to remember a 5, 12, 13, a 7, 24, 25. Can you think of the other one? It's 8, 15, 17. There's also 9, 40, 41, and of course these go on and on and on, but those 4 top ones there are the ones you use so much. If you memorize those, you're going to be able to do a lot of these without having to do Pythagorean theorem. Okay, flipping on over. So, new to you this probably in this course is the 3 more functions of trig, which are called cosecant, secant, and cotangent. These are reciprocal functions, meaning they're reciprocals of the original 3 functions. Cosecant is the reciprocal of sine. So if you find the value of sine and flip it over, you'll have the cosecant. Secant is the reciprocal of cosine, and cotangent's the reciprocal of tangent. So since sine was opposite over hypotenuse, cosecant is going to be hypotenuse over opposite. Since cosine was adjacent over hypotenuse, if we flip that over, secant is going to be hypotenuse over adjacent. And for cotangent, since it was opposite over adjacent, cotangent would be adjacent over opposite. So we flip all the original three to get the remaining 6, cosecant, secant, and cotangent. So here's our 5, 12, 13. That was one of the triples that I mentioned. So just looking at signs, so remember sign. If you need to, write down real quick, SOHCAHTOA, S-O-H-C-A-H-T-O-A. Need to be able to remember that real quick. So sine is opposite over hypotenuse. Look and make sure you can see which angle you're using. Opposite is 5, hypotenuse is 13. So the cosecant, the reciprocal of that, would be just flipping it over, hypotenuse over opposite. So go ahead and find the cosine and the secant of these as well. All right, and there are our answers. Okay, so find the missing sides of the special right triangles below. So we've talked about the 30, 60, 90 relationship. And the 45-45 relationship, hopefully remember on an isosceles right triangle, across whatever's across from the 45-degree angle, the equal sides, if those are called x, the hypotenuse would be x times root 2. That's in a 45-45 right or an isosceles right. And remember a 30, 60, 90, just like we said, across from the 30. I'm going to write it a different way this time. Whatever that is, we'll call that x. The hypotenuse is 2 times that, and across from the 60 is x times root 3. So, using that, take a second to find all the missing sides. For example, 5. That should be a review. Okay, so the first one, since it's 45-45, these sides are equal. So if this is 10, this is 10, and the hypotenuse is 10 root 2. This one, on the other hand, this is the tricky kind. Notice it's turned differently than the one that I drew. You are given the side across from the 60. So let's see if you did that one right. So the side across from the 60 is your root 3 side, your x root 3 side, and there's not a root 3 beside it. So we've got to find x, which is the side across from the 30. I'm going to call that x, but it's also called a here. So to solve this equation, what do I do to both sides? I divide by root 3. So x equals 20 over root 3. I should always rationalize if I can, which is 20 root 3 over root 3 times root 3 is 3. So ugly, but that is our side across from the 30 called a, or our x, 20 root 3 over 3. And then remember, to get our hypotenuse, we double what was across from the 30. So if we double 20 root 3, we'll have 40 root 3 over 3. Just double the top of a fraction to double the whole fraction. Okay, so that's our special right triangles, 45, 45, and 30, 60, 90. But what do we do if we don't have those special angles? That's when we have to use trigonometry, like this problem here. So we've got a 23-degree angle. So we can choose to use sine, cosine, or tangent to find the x and the y. Well, let's say we're going to find x first. Well, that we are given the opposite side, and we're given the adjacent side. So, or we're looking for the adjacent side. So which one has opposite and adjacent? I can use tangent as opposite over adjacent, or cotangent is adjacent over opposite, either one. I'm going to use tangent. So the tangent of the angle, be sure you write it correctly, equals the opposite side, which is 6, over x. Now we're going to do a little algebra to solve that. If we multiply x to the other side, x times the tangent of 23 equals 6. Remember, the tangent of 23 is just one number, so if we divide both sides by the tangent of 23, we'll get what we are going to put in our calculator. X equals 6 divided by the tangent of 23. Okay, so to make sure we can do that on our calculator, couple things about our calculator. First of all, sine, cosine, and tangent. Let me clear out the screen here. It's a little better. So sine, cosine, and tangent are right here above the y and the x and the y and the z and the t. And if you want the other three, secant, cosecant, and cotangent, you're going to go to Math down here, which is the blue button, 5. And if you can see there, you see you have angle there, but if you go down to number, I think it's after 9, there's a trig. If you choose trig. And then there is your sine, cosine, tangent, as well as the cosecant, secant, cotangent, and all of their inverses. So if you're looking for the other trig functions, they're under secant, 5, and then scroll down to trig. Okay, so I'm going to get out of that. So here, I'm trying to put in my calculator 6 divided by the tangent of 23. Another thing you need to check is my calculator here is in radians. It says RAD. It's a little blurry, but angles can be measured in radians or degrees. We're going to be using degrees in this class. So if you are in radians, you need to make sure you push mode, go down to where it says angle, and change that to degrees. Make sure you push enter twice, and now you can see the DEG, so I'm in degrees. So I'm going to put in here 6 divided by the tangent, so the blue button, tangent of 23. And then make sure you close your parentheses or it'll give you an error. 6 tangent of 23. And if I just push enter, it's going to give me basically exactly what I put in. So you need to push the approximate button, which is the yellow button and the little squigglies. Yellow, enter. That's approximately, and it gives me 14.135. So we're going to round to 3 places here. So x equals 14.135. Okay, so I'm going to stop right there and continue on the next video, but go ahead and see if you can set up a ratio. We just found x. See if you can set up a ratio to find y.